Okay, so, all right, that's enough about the inside of these planets. Let's take a look at the outer part that we can actually see. So, quick question, is this a solid surface that we're looking at right here on Jupiter and Saturn? Are we looking at a solid surface in these pictures? I'm getting some weird lighting issues here, but whatever. No, these are not solid surfaces that we're looking at, okay? So what we're seeing in these pictures is clouds, okay? Hydrogen and helium are colorless, so we don't actually see that hydrogen and helium, but we're seeing cloud covers. So there's so much cloud cover in these atmospheres that you can't even see the ocean that's underneath those clouds. Now, how are these clouds lined up? Let's talk all about these clouds. There's a lot of weird features in these clouds. Now, first of all, we'll go back to this picture of Jupiter. These clouds have a lot of organization to them. There's a lot of order to these clouds. Like if you had this rough pattern on your shirt, you wouldn't say you had a solid color shirt. What would you say this pattern is? What is the basic pattern we're seeing in these clouds here across this planet? What basic pattern do we have? Yes, stripes. Our clouds clearly don't have these stripe patterns. And on Jupiter and Saturn, these cloud stripes have names. Okay, well they're not individually named, but there's two different words we use to indicate the different colors of stripes. Okay, so if we look right here, and this is for Jupiter and Saturn. Everything I'm saying right now, just both planets. The light colored stripes, like this one or this one, are called zones. That's Z-O-N-E, okay? Light-colored stripes are called zones. Dark-colored stripes, like this one, or this one, or this one, are called belts. So light-colored stripes are called zones, and dark-colored cloud stripes are called belts. So let me show you, and again, you can see them right here on this picture as well. There's a belt, and this lighter colored stripe up here is a zone. So that's Jupiter and Saturn. Okay. Now, what's making them different colors? A lot of times people think that the different colors in these stripes, in the zones and belts, are from different kinds of clouds. But here it's actually simpler than that. It's elevation, okay? The zones and the belts are at different heights in the atmosphere, okay? And so essentially one is brighter and one is darker because of how deep they are in the atmosphere. So with that in mind, here's my question. Would we expect the darker colored belts to be lower in the atmosphere or higher in the atmosphere? And to help that, what makes them bright is reflected sunlight, essentially. Lower. That's correct. So the zones are higher, closer to the sunlight, or with less atmosphere blocking the sunlight, so they can reflect light a lot easier, so they appear brighter. Where as you go deeper into the atmosphere, it gets darker and darker and darker. It gets shadier, essentially. So you can think of the belts as just being shadier than the zones, okay? And again, it's okay if you get these questions wrong. We're learning here, okay? So the zones are high elevation clouds, the belts are lower elevation clouds. And they don't stay, zones don't stay zones forever, and belts don't stay belts forever. Because If these clouds are higher in the atmosphere, they're colder. And if they're lower in the atmosphere, they're hotter. But what does hot material want to do? What does a hot gas or liquid want to do? It wants to rise. That's correct. So essentially, the belts right now are low and warm, but that warmth makes them want to rise up and become zones. The belts become zones as they rise, but then they cool down and they want to sink back down, so the zones will eventually become belts as they sink, and then it just keeps going back and forth and back and forth. So these zones and belts are somewhat temporary. They change back and forth, okay? Now, here's the next thing. I actually want to show you a quick picture, or a quick video, essentially, of the clouds actually moving, so you can see how these clouds move around. Let me see if I can get this to work. There we go. So this is a sped up video of these clouds moving, and you can see that some of the material is moving from west to east, and some of the material is moving from east to west. But do you see any large-scale movement up and down, so north and south for these clouds? Are any clouds for a large part going north and south in this video here? No. Okay? So the zones and belts, all the clouds here on Jupiter and Saturn, and you can make a video like this for Saturn too, all the clouds are basically going parallel to the equator. Is that how clouds move on Earth? Is this how the clouds move in nice orderly lanes like this on Earth? The answer is no. No, they don't. So this is the most important question here about clouds. Get ready. Here we go. Why do the clouds not stay so organized on Earth? What makes our clouds go much crazier? Let me show you a picture that shows you what I mean. Here we go. Let me bring this down. Uh-oh. There. Nope. There we go. Here's a picture of clouds moving on Earth. We have a lot of chaos in our clouds. What causes the clouds on our planet to not just follow the equator? This is a harder question. Let's see if we can figure it out. And I'm going to show you something that will help you. Let me do something real quick. So check this out. Imagine my finger is some wind. When it's out here in the Pacific, it does, near the equator, it does tend to move similar to on Jupiter. But when it gets about right here, clouds tend to turn. Okay? Clouds tend to turn a little bit right here. When the clouds get right here, they tend to turn and go south. It's a little more chaotic than that, but basically that. So what's causing it to turn? Land. That's right. Land. When the land sticks up, it gets in the way of the air currents that are carrying these clouds. And so if we look back at Jupiter and Saturn with their perfect stripes like this, or near perfect stripes, what does that tell us about what's going on underneath these clouds? If the clouds never turn like this in large scale motion, what does this tell us about what's going on underneath the clouds here? No land. That is correct. So here, this is the crucial thing. Even though we have never been to the ocean of Jupiter, we know that it can't have land, Because if there was a continent sitting, you know, in, like, if there was a North America right here, we would know it from the clouds because the clouds would be turning when they ran into that continent. So we know that Jupiter and Saturn don't have land because the pattern of the air currents stays very organized. Okay? Does that make sense? Hopefully that makes sense. I'm going to assume that makes sense. All right. So, zones and belts. Both Jupiter and Saturn have zones and belts. Now, the clouds themselves on Jupiter and Saturn are not necessarily made of the same stuff as the clouds on Earth. What are the clouds on Earth made out of? What are Earth clouds made out of? Don't overthink this. Pretty sure you guys can get this question. What are the clouds made out of on Earth? Yes, that's correct. They're made out of water vapor. They're made out of water, okay? What do we typically think of the color of water clouds being? White. That said, the intense gravity on Jupiter would tend to make these clouds pressed tightly together. So these are going to be very, very, very thick water clouds if they're there. And you probably have seen some thick clouds before. We typically think of them as being sort of gray. But if you get them thick enough, really thick, like beyond the thickness that we're usually dealing with on Earth, we would expect those clouds to start turning roughly the color of the ocean, okay? So a bluish gray color. Now, do you see on Jupiter and Saturn here, do you see a lot of dark blue, bluish gray color in here? Do you see a lot of dark bluish gray? No. But it turns out there are water clouds here on Jupiter and Saturn. There are water clouds. We just can't see them from space. So where are these water clouds? Here's a hint. There's more than one kind of cloud on Jupiter and Saturn, okay? On Jupiter and Saturn, there's more than one kind of cloud. Why can't we see the water clouds? And here's a hint. It's because of where they are. Where are those clouds if we can't see them? That's right. That's right. They're below the clouds that we can see. So if somebody said they're below the zones and belts, they might be on the underside of the zones and belts. The important part is, yes, you got the right idea. They are too low. There's other clouds on top of the water clouds. Okay, so, and again, somebody asked, we are talking about Jupiter and Saturn so far this whole time, except for some slight differences I pointed out between them. Okay, now, so, what are these clouds made out of? For Jupiter and Saturn, there are 3 kinds of clouds. And as we said, the very bottom layer of clouds is water, okay? If you look right here, what they're trying to show on here is the cloud layers of Jupiter, but again, the cloud layers on Saturn are the same thing, and like we said, the very bottom layer of clouds is water clouds, okay? The other 2 cloud layers are different substances. The top layer is ammonia. Okay? Would you like to hang out in an ammonia cloud? Is it a good idea to hang out in ammonia? No. Someone's right. No, you don't want to hang out in ammonia, right? Because ammonia is the same caustic substance we use in a lot of cleaning fluids. But in our cleaning fluids, it's usually diluted. Here, that's basically pure ammonia up in that upper level of clouds. So that would be a bad idea to hang out in as a human being. The central layer of clouds is just a different substance called ammonium hydrosulfide. It's just a different chemical. Sorry for the really long name. But yeah, to review, the 3 cloud layers on Jupiter are ammonia, ammonium hydrosulfide, and then water. That's the same 3 cloud layers on Jupiter and Saturn. Okay? The ones we can see from space are these upper clouds here. Okay? Now, there is something we have to point out, though. Do the clouds on Saturn look exactly the same as the clouds on Jupiter? No. What's different about how the clouds look here? How do the clouds look differently on Saturn? What's the difference between this picture and this picture? What's different? And I can show you guys some close-up pictures to help that out. Here's a close-up picture of the clouds on Jupiter. And here's a close-up picture of the clouds on Saturn. Yeah, they're much smoother looking, right? It looks like there's like a lot less detail going on here. Okay? So the first question we have to figure out is, what is that detail? And remember, I showed you guys that little video that some of these cloud layers are going east and some of them are going west. And so what we're seeing, all of that swirly stuff in the clouds there, is that when clouds rub against each other, there's friction. And that friction causes the clouds to turn a little bit at their boundaries. So basically, turbulence in the clouds is messing up the perfect stripes here. And so what it looks like is there's less turbulence on Saturn. But this is an optical illusion. Saturn has just as many spots and swirls and turbulence as Jupiter does. It's just much harder to see, okay? And to help you understand why that is, I'm going to bring up another thing on stream here. It's actually a pretty simple difference that causes this, but it might be a little bit hard to wrap your head around, okay? So let me show you this. Here we go. Got to change that. Okay. Some small technical difficulties. Let me see if it'll come up. Come on. You know you can do it. Okay, it's not really cooperating with me right now, so that's okay. You have to visualize this. So let me go back to the 3 layers on Jupiter, okay? So check this out. These are the 3 cloud layers on Jupiter. I said that Saturn has the same 3 cloud layers, but they're more spread out. The water level is deeper down, and the ammonia level is higher up. And what that does is it changes the amount of detail we can see from space. When you're looking at these cloud layers, it's like looking through a fog, okay? When you look at a fog, if somebody is standing on the edge of the fog, right on the outer edge of it, you can see them, okay? But if they go too deep into the fog, you can't see them. So because Saturn's cloud layers are more spread out, when we look down from space, less of the detail is close enough to the top for us to see from space. The detail is there, but it's deeper into the atmosphere where we can't see it because it's too deep in the fog, okay? So if we could see deeper into the fog on Saturn, we would see just as much turbulence as on Jupiter. Now, here's the follow-up question. Why are Jupiter's cloud layers pressed more tightly together, making it so we can see more of the detail? Why are Jupiter's cloud layers pressed more tightly together than Saturn's cloud layers are. There's a simple reason for it, and you guys have already pointed it out. What's different about Jupiter that makes it so it can press those clouds together tighter? Yes, that's correct. That's correct. Higher gravity. So if Saturn had just as much gravity as Jupiter, it would take its cloud layers and press them together like Jupiter's are, and then Saturn would look a lot more like Jupiter. Okay? So it's basically all of the differences that I've told you so far about Jupiter and Saturn just come from Jupiter having more gravity than Saturn does, okay? They're essentially almost the same, except for small differences caused by the higher gravity of Jupiter, okay? So higher gravity makes the cloud layers push together more tightly, which makes Jupiter look more detailed from space. It's an optical illusion. Okay, now, with that in mind, I'm going to tell you guys some features that we only name on Jupiter for a little bit. Everything up until now has been Saturn and Jupiter, but because we can see so much more detail on the surface of Jupiter here, that we name a lot more things. Okay, so this next thing is Jupiter only, and it's something that some of you guys have already pointed out. Okay, other than stripes on Jupiter, what other kind of shapes do we see in certain places on here? Other than stripes, what else does Jupiter have in terms of just basic shapes? Yes, there's a bunch of spots. There's a bunch of spots on Jupiter. Let me show you a picture of one of the poles of Jupiter. I believe it's the South Pole. You can see those spots a little bit better. See, there's a bunch of spots all over Jupiter. And Saturn, if we could see deeper into its atmosphere, has these spots too, but we don't give them a name on Saturn because we can't see them from space. So on Jupiter only, we have two names for these spots that are all over the place. One of them is these little white ovals. What do we call these little white ovals? We call these little white ovals white ovals. So the white ovals are called white ovals. Not a very imaginative name, but you know, hey, you know exactly what they're talking about when you say the name. With that in mind, can anybody guess what we call all of these little brown ovals? What do we call those brown ovals? Brown ovals. Good job, guys. You guys are smart. Good job. So again, on Jupiter only, we call these white ovals and brown ovals. What are they? If we could zoom really far in on them, we could get a better idea of what they are. But I'm going to do something better. I'm going to show you guys an enhanced picture where they've used things like radio light and a few other types of telescopes to give us a little bit more detail on this same picture. So here is a enhanced image of the exact same region. There we go. Okay, so I think this picture looks really cool. This is not a true color image. They're just coloring this in so you can see the detail a lot better. And you can see that these ovals all have spirals on them. All of the ovals, all of the white ovals and the brown ovals are spiraled. So what is basically oval shaped, made out of clouds, and is spiraled? Yes. Looks like we're getting it. Looks like we're getting it. These are storms. These are hurricanes. So Jupiter is completely covered with hurricanes, okay? And it's a little bit hard to tell in this picture, but these hurricanes, because we can see them from space here on this picture, remember, this Jupiter's a lot bigger than Earth, so some of these hurricanes are much bigger than the entire United States. So these are very big hurricanes, the white ovals and brown ovals. And again, Saturn also has these hurricanes all over the place. They're just deeper in the atmosphere, so it's harder to see them from space. So we don't call them white ovals and brown ovals on Saturn, okay? Now, are the hurricanes on Earth bigger than the United States most of the time? No. Most of the time, we typically think of hurricanes being as big as a few states, not as big as North America, right? So keep that in mind. Last thing I want to say about white ovals and brown ovals is this. Can you guys figure out what's different about the white ovals and brown ovals? Why are some of the ovals white? Why are some of these storms white and some of these storms brown? What's probably different about them? Here's a hint. It's related to some stuff we've talked about already in this video. There might be different chemical compositions from one storm to another, but the main thing giving them different colors is the elevation. It's the elevation again, just like the zones and belts. So which ones are higher? Which storms are higher, the white ovals or the brown ovals? Which ones are higher, white ovals or brown ovals? The white ones. So just like the zones being brighter because they were higher in the atmosphere, the white ovals are also brighter. They're reflecting a little more sunlight because they are higher in the atmosphere. The brown ovals are deeper down in the atmosphere where it's essentially shadier, okay? So same as the zones and belts. All right. Now, one last important feature that I want to talk about on the surface of Jupiter. And this is definitely a Jupiter-only feature, and it's something that a lot of you have probably already heard of at some point if you've seen anything about planets. What is the most famous feature on the surface of Jupiter here? Yeah, this big red spot right here. Does anybody know what we call this big red spot right here? What do we call this big red spot? It's in almost all of the pictures of Jupiter that I've shown you guys. It's even in this picture, if you look right here. It's called the Great Red Spot. So the Great Red Spot is the most prominent feature on the surface of Jupiter, okay? And I'm going to show you some close-up pictures of it. Here you go. Here's a really close-up picture of the Great Red Spot. Can you figure out what the Great Red Spot is? Yes, that's another storm. That's another hurricane, okay? That is not just a hurricane. It is the biggest hurricane in the entire solar system right now. And how big am I talking? We've taken pictures of it at different times, and it's changed size. At its smallest, it's about twice the width of the Earth. And at its largest, it's about 3 times as wide as the Earth. So when it was 3 times as wide as the Earth, if you put it on the Earth, this hurricane could almost wrap all the way around our entire planet. So clearly, this is a ridiculous hurricane. And it also has faster wind speeds than hurricanes usually have on Earth. The average for this particular storm is about 250 miles per hour. So it's a very, very strong hurricane, and it is huge. Now, somebody's asking, does it ever stop? That is a good question. Does anybody know how long we have seen this great red spot here? How long have we been seeing the great red spot on Jupiter? Here's a hint. It's been a while. Definitely for as long as any of us have lived. The Great Red Spot has been on Jupiter at least as long as we have had telescopes good enough to see the clouds on Jupiter. So as far as we know, it's at least been there hundreds of years. It's potentially been there thousands and thousands of years. So it lasts a very, very, very long time. And again, it lasts way longer than our hurricanes. It can get up to 3 times the width of the entire Earth. So it's way more extreme than our hurricanes. Our hurricanes only last, a few weeks before they die, and they never get this big. So here we go. Let's put it all together. Can you figure out why the hurricanes on Jupiter can last hundreds of years when ours can't? What's different about Jupiter? Why can Jupiter's storms get this big and just keep going and going and going? You guys are getting it. You guys are getting it. No land. What stops a hurricane? Florida stops a hurricane, right? We live here. We know how it is. When the hurricanes hit land, they don't last very long at that point. They can last for a long time when they stay over the ocean, but as soon as they come onto land, they break up. So the reason these hurricanes can get so big and can last so long is it can... there's just no land to stop them, okay? So that's the Great Red Spot.